Good evening, sir.
Good evening, sir.
Good evening, everyone.
Good evening, sir.
Good evening, sir. Good evening, all of you. We'll be starting the class just in 2 minutes. Till everyone joins, we are waiting for everyone. We'll wait for 2 minutes only. Okay, then we can start with the class. Please look at the हाँ राइट टेपो ना टेपा वो टेपा टे ले लिए जाते चलो ना बोलो Okay, so I think everyone has joined. Now we can start with the class. Am I audible to everyone?
Yes, sir.
Okay. In case if you are facing any problem during the class, just inform either through the message or through the WhatsApp group also. Through the WhatsApp, I think everyone should have joined help and support group. Okay. So you can check from there also. You can update from there also. Condenser and which one they can do? So is the screen visible to everyone?
Yes, sir.
Answer the note. So change to please. No, no. Answer the note. Sound कर देना. 500 का नोट दे दो तो फालतू के. Okay. So in the last class we had studied about electric charges, right? And we had seen how the electric charges flow through the wire that we call as the electric current. Okay. Just just okay. So see what all things we had discussed in the last class about the electric charges. So first of all, we had discussed about the SI unit of charge. So what is the SI unit of charge? Yes,
Coulomb,
who
sir.
will tell me the SI unit of charge?
Coulomb, sir.
Coulomb, very good. So SI unit of charge is Coulomb. And then next question is, so SI unit is Coulomb. Then the next question, that how much charge is there on one electron?
One
Charge
minus,
of,
sir,
yeah,
minus 1.6 multiplied by 10 power minus 19.
very good. So everyone should remember this. The charge of electron is negative 1.6 multiply 10 to the power 10 to the power minus 19. Okay. So this is what the charge of an electron is there. Similarly, we had seen charge of proton. So charge of proton is also the same. Yes, a proton also has the same charge. Only difference is that it has a positive charge. Eh, eh, It has a charge of 1.6 multiply 10 to the power minus 19 coulomb. So this is the amount of charge that is held by each of the electron or a proton, right? Then we had seen a few more things. We had seen how to draw the symbol of a cell. Okay, so can everyone draw the symbol of cell? How do we represent a cell and a battery? Yes, can you people draw the symbol of cell? How does the symbol of cell look like?
So we need to draw a bigger cylindrical shape which represents the positive and the smaller connected to the positive cell in cylindrical shape that is called negative.
Okay, so we have to draw two vertical lines to represent a cell. So the next thing we draw here is the symbol of cell. In the symbol of cell, it is represented by two vertical lines. One vertical line is a bigger one, and the other vertical line a smaller one. The bigger vertical line represents a positive terminal, and the smaller vertical line represents the negative terminal of the cell. So you have this one as the positive terminal, this one as the negative terminal of the cell. Okay. Then what are the symbol of battery?
Ma'am, yes, sir.
Yes. How can we draw the symbol of battery?
Sir, two cell diagrams, if combined together, forms a battery.
Okay. So two cells combined together form a battery. Then how do we combine two cells? What is the way of connecting two cells?
The positive cell to the negative cell to
Hmm? The positive of one cell.
negative terminal.
Okay, the positive of one cell is connected to the negative of the other. So it is something like this. I think you should see we have a positive terminal, then a negative terminal. So this represents a cell. Now we draw another cell in the same way, like this, a positive terminal and a negative terminal. So this now represents a cell. Then you can draw another. So if you connect the negative of one cell to the positive of the other like this, so you have now made a battery. Okay. So this is a battery, the symbol of battery. Now See, whenever a circuit is working, today we will discuss about two things. Today we will discuss about current and we will discuss the conditions necessary for a circuit to work or conditions necessary for a bulb to glow. What are the conditions necessary for a circuit uh, or any device to work? Okay. So what are the conditions necessary for a bulb to glow?
Sir,
Yes.
it needs a cell to release the energy,
Yeah. And
and a wire which is needed to pass the electricity,
mhm.
and a switch which is manipulated under our control. We can open the circuit or close the circuit according to the switch.
Okay. Okay. What if there is suppose if there is we do not have a switch, so will the bulb glow?
No, sir.
Yes, the bulb will glow. Even if there is no switch, the bulb will glow. Okay, we provide the switch just to have so that uh, the switch can we can turn it off. Okay,
Sir,
even if there is no switch, then also the circuit will glow. So what are the necessary conditions?
sir, switch is
Yes,
provided to turn on the switch and
no, it's
turn
not
on the lights and turn
necessary.
off light.
If there is no switch, then your bulb will always be on. It will never go off. Okay,
Okay, sir.
it will never
Okay,
go off. It will always be on, and hence it will always be glowing. Okay.
okay,
So what are the conditions necessary for a bulb to glow? The very first condition is that the circuit should be complete. Okay. The circuit should be complete. So even if the circuit is broken from anywhere, if the circuit is broken anywhere, the bulb will not glow. So this is the first condition. The circuit should be a complete. The second point which is necessary is that the presence of
Oxygen.
no the
present
presence
of the
hmm,
present of
yes
Ma'am, sir, filament, sir.
light.
no not filament, the presence of a
Light.
voltage source, presence of a voltage source like battery or cell. Okay, so there should be cell or battery present in the circuit. So there should be a voltage source present in the circuit, which can be a cell or a battery. Then only the circuit will be complete. Then only the bulb will be.
Sir, the potential difference, sir.
Yeah, the potential difference. So that is why we need a voltage source, like the cell or a battery. So if these conditions are met, the bulb will glow. Okay. So if you draw any, suppose if I draw a circuit like this, let's say, even if I do not use a switch, I just use a cell and I use a bulb. So here you have a cell, then you have the bulb. Now, will the bulb glow?
Yes,
Yes,
sir.
No, sir. The bulb
yes.
flows the wire.
Yes, sir. Yes, sir. It will glow.
Okay. Who says no?
It will glow. It will glow.
Yeah, it will glow. Who says no? Is there anyone who says no? See, we are meeting our two conditions. First of all, the circuit is complete. We see that circuit is not broken. The circuit is complete, and we observe that there is a voltage source. There is a cell in the circuit, so it will run. Now, if I break the circuit, suppose I break the circuit from here, I break the circuit from here. So will the bulb glow?
No, sir.
Bulb doesn't glow.
Yeah, the current will not flow and the bulb will not. Even if I break the circuit from here, so then also the bulb will not move.
Yes,
Okay.
sir.
Yes. So I think you have understood that how do we check that these two conditions should be met. A circuit should be complete and a cell, there should be the presence of a cell or a battery. Okay. The next thing is a necessary thing. We now go to defining electric current. Okay. Okay. So what is electric current? Let's try to define electric current. Okay. So what is electric current? We define it as the rate of
Flow of electric charge through the wire.
the rate of flow of electric charges. The rate of flow of electric charges is called electric current. Okay. So what is the SI unit of current?
Coulomb. Coulomb.
No, for current,
Sir, ampere.
ampere. Very good. So SI unit of current is ampere. SI unit of electric current is ampere, denoted by the symbol capital A. It's denoted by the symbol capital A, ampere. Now, see how do we find out the electric current? The formula of electric current is something like this. This is a formula which can be asked for Olympiad questions. You can be asked for Olympiad questions. The formula is current I is equal to Q by T, where Q represents the charge
Charge.
and
T represents time.
time. So the amount of charges flowing in a given time will be called as electric current. Okay. So let us try to find out do a small question. Okay. So if 5 ampere current flows through a wire, if 5 ampere current flow through a wire, then how much electric charge flow through it how much electric charge flow through it in 10 seconds. So let's see who can find out. So start solving. Let's see who can find out the answer. If 5 ampere current flow through a wire,
Sir,
yes,
15, sir, 15.
50. How you get
50,
50?
50. 10 into 5,
50.
50.
50. Okay. So, and the unit of charge is?
50 seconds.
Its answer is 50, but the unit of charge is coulomb. Okay. So, we will use the formula. We will use the formula I equals Q by T. But we want to find out Q. So, Q will be equal to I multiply T. If you take this T to the other side, if you take T to the other side, it will become multiply. So hence you have Q equals I into T. Now by putting the value, we get I as 5 and T as 10. So the amount of charge is 50 Coulomb. You should also write Coulomb as the SI unit of charge is Coulomb. Okay. So SI unit is Coulomb, or we can also write it as ampere second. So SI unit of charge is Coulomb. Okay, hence we get here 50 Coulomb of charge. Okay. Now can we do another question?
Yes, sir. Yes, sir.
Okay. Very happy. Very happy. Very happy. Okay. 12 is 20 Coulomb charge. 20 Coulomb charge flow in 10 seconds. Okay,
Sir,
so yes,
2 amperes of current, sir.
very good. So 2 ampere of current. You will get your answer as 2 ampere current. Okay. So I think now everyone has understood how to find out the answer to such questions.
Yes, sir.
Yes. So I equals to Q by T. Just use Q is 20 and 20 by 10 is 2. So you get your answer as 2 ampere. Okay. Now we move to the next part, that can the electric current pass through all the substances?
No, sir. No, sir.
Yes. So current cannot pass through all the substances. There are certain substances through which electric current can pass. There are
Insulator.
certain yes, and there are certain substances through which the electric current cannot pass. So the substances through which electric current cannot pass will be called as insulators, and the substances through which electric current passes are called as conductors. Okay. So you have two types of substances called as conductors and insulators. No, thank you. No. So conductors, they are the substances which can conduct electricity. Insulator are the substances which cannot conduct electricity. So I'm giving you some of the objects, and you have to tell that whether they are conductors or not. Yes, and Lasya,
Sir, yes, sir. In the first slide, how much electric current is flowing? You wrote it like another G, sir. It is true, sir.
what happened in this problem?
In the first slide, sir,
Yes.
you wrote like for true another G, sir. Is it true or any other word, sir?
Where? Here.
No, sir. Down.
Just repeat your question slowly.
Sir, the before page, sir, the third page, whatever you're explaining, sir, in that the first slide, you wrote as for true second G, sir. What is it, sir?
I'm not getting your question. What you are asking? If you can write it and share, so I'll be getting maybe. I'm not able to get your question.
Okay, sir.
I'm not able to listen it properly what you are saying.
Okay, sir.
So if you can write it and share to my number, then I'll look to it. Okay. I'll look to it once you share it over there. Okay. So see, conductors are the substances which can conduct electricity. Insulator are the substances which cannot conduct electricity. For example, we have metals, all the metals. We have sand. We have water. Let's leave water. Plastic.
Sir, I guess
Right.
now I'm audible, sir.
Yes, you are audible.
Yes, sir. Sir, the first line, how much electric current is flowing, it is given, right, sir? So for that, is the word through, sir? Like 2 times G is there.
Okay, here typing error you are saying. Okay, thank you. Now
Yes,
it's correct.
yes,
Okay. So conductor and insulator, metals, sand, plastic, wet salt. If you identify these substances, you have, let's say, wood, paper, rubber. If you have a blade. Okay. So out of this, which all substances will be good conductors of electricity? Which will be the conductors and which will be the insulators? So what can we say about the metals? Are they conductors?
Yes, sir.
Yeah. Yes. Metals are conductors. Sand, sand is an insulator. Plastic is an insulator. Wet salt is a conductor. Wood is an insulator. Paper is an insulator. Rubber is an insulator. And blade is a conductor. So we can easily identify these substances, that which substances are good conductors. If the substances are made up of metal, they will be good conductors. Okay. Now let us see about the liquids. What about the liquids? Can we test for a liquid to conduct electricity? Yes?
Yes, sir.
Yes. So let us see how to test the liquid for their conductivity. So next we have testing a liquid. Liquid for conductivity. See. So for this, again, we have to take a circuit. We have to draw a circuit, something like this. We take a container and fill this container with the liquid. So for example, suppose we want to test for water, so we will fill it with water. If it is some other substance, so we will fill this with that substance. So this is how we fill it, and then we can test it. So for testing, we will again complete the circuit. To complete the circuit, we will use two rods here. As we can see, the two rods, they are not in direct contact with each other. Now, we will try to complete the circuit by using a bulb. So here we will use a cell and a bulb. So we use a cell as the source of potential. Then we use a bulb. So we use the cell and the bulb. Now see, out of will this bulb glow or not?
Oh, sir. Yes,
Okay.
sir.
So this bulb will glow only if the liquid conduct electricity. If the liquid does not conduct electricity, so the bulb will not glow. Okay.
Sir,
If
water is a conductor.
okay, see, water. If you talk of pure water, is not a conductor. Okay, pure water is an insulator. So a very important key point. Pure water is an insulator. So this is an important point here. pure water is insulator. However, impure water is a conductor. Impure water is conductor of electricity. So we'll see how the different substances conduct electricity, how can they be conductors and how can they be insulators. If you talk of water, so water is a bad conductor in its ionic form, in its pure form. If you take pure water, so pure water will be a bad conductor. But if you take impure water, so impure water will be a good conductor. Why it is so? Because the impure water produces ions. The impure water produces ions, and hence it will be a good conductor of electricity. Whereas pure water will not produce ions. Okay, so pure water will not produce ions, and hence it will not be a good conductor of electricity. So pure water cannot conduct electricity. What about lemon juice? What can you think of lemon juice? Will lemon juice conduct electricity?
Yes, sir.
Yes. Lemon juice will conduct electricity. What about sugar solution? What about sugar
Yes,
solution?
sir. Yes, sir. It is also an impure solution.
Yes. It is also an impure solution to conduct electricity. Okay. So in this way we can see the substances which can conduct electricity and the substances which cannot conduct electricity. Right? So in this chapter, we will also see the substances, all the liquids. We will be testing all the liquids for their conductivity. So this is the setup by which we can test any liquid. If it conducts electricity, the bulb will glow. If the substance does not conduct electricity, so we will say that the bulb does not glow. But now there can be a small problem over it. Can anyone think of that problem? What problem am I talking of? Okay. So see, I will discuss what is the problem. The problem is with the bulb. Okay, how many of you can tell that how a bulb works? Can anyone describe me how the working of a bulb?
Sir, it works with a filament which is with high melting point and absence of oxygen.
Sir, it
Oh,
works with battery and
yes,
with battery
with the battery, yes, and
with wire.
okay. See, basically how the bulb starts working. When the bulb is connected in the circuit, electric current flow through it, and the filament of the bulb heats up. Okay. When the filament heats up, the heated filament starts glowing. Yes. So when the filament heat up, it starts glowing. Huh? Okay. See, the working of bulb, it is based on the filament heats up. So the first point is that filament of bulb heats up and start glowing. Okay. Now, what can happen? What can cause a problem is that if suppose there is very small amount of current passing through the bulb. So if very small amount of current passes through the bulb, sufficient amount of heating will not be produced, and hence the bulb will not glow. Right? So in that case, the bulb will not glow. So therefore, we will say the bulb cannot work. Even if our solution is conducting, still the bulb will not. So what is the solution? What can we do? Anyone can anyone provide any solution?
Sir, we can use LEDs.
Yes, we can use here LED bulb. We will use here LED bulb. So LED bulb can be used. LED bulb. Yes. LED bulbs, these bulbs can glow even with small current. Can glow even with small current. So these bulbs can glow even with small currents, and these bulbs will be called as LED bulbs. The full form of LED is light emitting diodes. So we will be replacing our in the circuit. We can replace the bulb with LED. Whenever we want to test for the electric current, we will be using LEDs. So what is the full form of LED?
Light emitting diode.
Diode. Yeah, light emitting diode. Okay. Okay, everyone. Bye, everyone. I'll send this PDF. Do revise it. And in the next week, you will have a test from physics portion also, whatever we have studied. Okay.
Sir,
Bye,
notes you
everyone.
will post it, sir, the app.
Yes, on the WISE app. On the WISE app, you will find the resources section. Over there, you will find the PDF.
Okay.
Okay. Okay. Bye, everyone. Good night.
Sir,
Yes.
sir, this is IIT.
No, we are going a little bit higher. A little bit higher means, see, this is foundation level. Foundation of IIT. Okay. IIT, basic IIT study starts with grade 11. This is the foundation of IIT. We call it as foundation course. Okay. So all these things you will not find everywhere. Like how much charge is there on an electron, everything. This depth knowledge you will not get everything. Okay. Bye, everyone.
Bye.
Thank you, sir.
Okay, bye.